Usually when we talk about a scientific model in this deep dive, especially something like standard particle physics, there is this expectation of just, well, absolute precision.
Right, like engineering.
Yeah, exactly.
Yeah.
Like you break your arm, the X-ray shows that jagged white line, and the doctor just points at it and says, there it is.
It's binary. It's clean. Because, we fundamentally crave things to be visible, right? To be perfectly categorized into neat little boxes.
Definitely.
Or, in the case of physics, neat little points. We're basically taught from middle school that the universe is just this giant game of billiards.
Right, just solid little balls bouncing off each other.
Yeah.
But then you step into the world of fundamental reality, the absolute bedrock of what makes up you, me, the entire universe, and suddenly that X-ray machine is just broken.
Yeah, completely. We're looking at a structural landscape that is incredibly murky.
So murky. And the
Yeah.
deeper we go into the atom, the less solid things become, right?
Exactly. And the more we end up relying on abstract mathematics that, frankly, defy common sense entirely.
Which is exactly why today we're doing a deep dive into a 2026 paper by Sriman Barua. It's called Unified Vortex Theory of Atomic and Nuclear Structure. And it asks a question that might honestly break your brain a little bit.
It's a massive paradigm shift.
It really is. The question is this: what if everything you thought you knew about the building blocks of the universe was basically a mathematical illusion?
And, to be fair, a very successful illusion, mathematically speaking.
Oh, sure.
The standard model of particle physics has given us computers, lasers, nuclear power. It works, but it is fundamentally still an illusion.
Right. So our goal for you, listening to this right now, is to kind of unlearn that idea of the universe as a giant empty void filled with tiny bouncing solid point particles.
Throw the billiard balls out.
Exactly, throw them out. Instead, we want you to reimagine the universe as a continuous, elastic, energetic net.
Mhm.
And in this net, matter, the stuff making up your headphones, your body, the stars, it's nothing more than a localized topological defect.
A knot in the fabric itself.
A knot, yeah. But to really appreciate how radical this is, we kind of have to look at why the standard model is failing us at the conceptual level first.
Right. So the model that has dominated physics for decades relies incredibly heavily on point particle abstractions. It treats things like electrons and quarks as literal dimensionless dots.
Dimensionless, meaning zero volume.
Exactly zero. They take up zero physical space. Yet somehow they possess mass, charge, and spin.
See, that right there. How can something with zero size have mass? Because, if it has no volume, its density should technically be infinite,
And
right?
it is infinite. And that is the dirty little secret of 20th century physics.
Wow.
Yeah. When you plug a dimensionless point particle into the standard equations for gravity or electromagnetism, the math just blows up. You get infinities everywhere.
Yeah.
Like the energy of an electron's own electric field interacting with itself becomes technically infinite.
So what do physicists do? Do they just cheat?
Well, they use a mathematical process called renormalization, and even Richard Feynman, who literally helped invent the technique, called it a dippy process and hocus pocus.
Wait, really? The guy who invented it called it hocus pocus?
Yes, because it is essentially sweeping the infinities under the rug just so the equations spit out usable numbers. And it works phenomenally well for calculations, don't get me wrong.
Right. We have lasers and computers.
Exactly. But conceptually, it tells us that our foundational premise, the point particle, must be physically wrong. A zero-dimensional dot is just a mathematical placeholder. It is not physical reality.
So this paper, this new absolute medium or AM model we're looking at, it just throws that entire concept out the window.
Completely out the window. It replaces those magical dots with pure fluid-like mechanics and topology. No magic dots required.
No magic dots. I love that. But to understand how a single invisible medium can actually create the entire universe,
Yeah.
we need to understand the fundamental mechanics that govern this energetic net, right? Like, what exactly is the absolute medium?
Okay, so think of the absolute medium, the AM, as a continuous elastic net that fills all of space. Actually, wait, no, it doesn't fill space. It is space.
Oh, I see. So space is not an empty container holding stuff. Space is the stuff.
Exactly. And Barua gives us some very specific testable numbers for this fabric, which is crucial because, a theory without numbers is basically just philosophy. We need hard data.
Right. So first, there is a fundamental length scale to this net. It's called L-fund. And this is roughly 3.34 nanometers.
3.34 nanometers.
Okay, so if you picture the AM as this three-dimensional grid or mesh, 3.34 nanometers is the exact size of the tiny microscopic squares making up that mesh.
Got it.
Second, it has an ambient density. We call it rho zero. And that value is 2.1 times 10 to the negative 26 kilograms per cubic meter.
Okay. 10 to the negative 26 kilograms per cubic meter. That is incomprehensibly light. Like, you can't even weigh that on any scale we possess.
You definitely can. But that specific number is actually a massive revelation.
Really? Why? Because mainstream cosmology has spent the last few decades absolutely panicked over dark energy. You know, this mysterious, invisible energy that supposedly permeates the vacuum of space and drives the expansion of the universe.
Right. You hear about dark energy all the time in sci-fi and pop science.
Well, when cosmologists calculate the density of this dark energy, it perfectly matches 2.1 times 10 to the negative 26th kilograms per cubic meter.
Wait, it matches exactly.
Exactly. The AM model says we don't need to invent some mysterious dark energy to explain it. That value is simply the baseline ambient density of the universal net itself.
Wow. Okay, so the vacuum isn't empty. It just has a very specific, incredibly low density.
Yeah.
That makes so much sense. So that leads us to how this net actually functions. The paper outlines 3 core principles, right, for anyone totally new to this.
Yes, 3 core principles. Principle number 1 is the volumetric coupling principle. Basically, matter couples to the medium through its volume.
Okay, let's translate that out of physics jargon. What does that mean for me sitting here?
Okay. Historically, gravity has always been described as spooky action at a distance. You have the Earth over here, the moon over there, empty space between them, and somehow they just pull on each other.
Right.
Even general relativity, which says mass bends space-time, still treats mass as an independent entity sitting in space-time.
Oh, like the classic bowling ball and a trampoline metaphor.
Yes. And that is exactly the metaphor we need to discard today.
Toss it out. Okay.
In the AM model, gravity is a mechanical flow. Matter doesn't sit on the net. Matter is made of the net.
Okay, so because matter takes up volume in the medium, it creates a localized flow, like a current in the density of the net.
Precisely. So the local gravitational acceleration you feel right now, it isn't invisible graviton particles pulling you down. It is the physical mechanical flow of the absolute medium pushing toward the Earth's center. You are essentially caught in a cosmic river.
So it's like being in a swimming pool and getting pulled toward a massive open drain. The water is physically moving you.
Exactly.
That's wild. Okay, so what about principle number 2?
Principle 2 is the nonlinear elasticity principle. This dictates how the medium responds to being stretched or compressed by that flow we just talked about.
Okay, like a spring.
Well, it's not like a simple spring. With a simple spring, you pull it an inch, and it pulls back with 1 pound of force. You pull it 2 inches, it pulls back with 2 pounds. It's linear.
Right, predictable.
But the medium's response is nonlinear. The pressure field decays proportionally to the square of the mass over the radius to the 4th power.
Okay, so it drops off extremely rapidly.
Yes, extremely rapidly, but in a highly mathematically rigid way.
Got it. And then we hit the 3rd principle, which is where things get truly weird, I think. Topological folding.
Yes, this is the official death of the point particle.
Because the paper states that matter doesn't actually exist as a separate entity at all. Like, there's no hard, solid stuff anywhere in the universe.
None. Matter is simply a region where the energetic net is tightly folded in on itself. It's a topological defect.
A defect.
Right. And the degree to which it is folded, the folding density, that determines the strength of all the physical interactions in that region.
Okay, let me try a metaphor here to ground this for everyone listening. I want you to imagine a massive, incredibly dense, perfectly clear sponge that just fills the entire room you are sitting in right now.
Okay, a clear sponge.
Yeah. Now, if I reach my hand into the middle of that clear sponge, grab a handful of the material and just pinch it and twist it really tight, I've created a hard, dense little knot in the center.
A structural deformation.
Right. In this analogy, that twisted knot of sponge is what we call matter. It feels solid compared to the rest of the sponge because the density is hyper-concentrated right there.
Yes.
But importantly, because I've twisted it, I've created immense tension. The rest of the sponge around the knot is being stretched, right, pulled inward toward that twist. And that stretching of the surrounding sponge is gravity.
You've hit all 3 principles perfectly with that. The knot itself is the topological folding. The inward pull of the surrounding sponge is the mechanical gravity dictated by the volumetric coupling principle.
And how that tension distributes outward through the room. That's the nonlinear elasticity principle.
Exactly. You nailed it.
Okay, I mean, I love a good metaphor, but I have to push back here. It's a neat picture, but if matter is just a knot in a continuous clear sponge, what defines the edge of a particle?
What do you mean?
Well, when experimental physicists smash things together in the Large Hadron Collider, they don't see blurry sponge knots. They see distinct, measurable particles with incredibly specific masses and charges. How do we get perfectly distinct particles if it's all just one big, continuous fluid?
That is the philosophical wall we have to climb over. Standard physics totally programs us to think of a particle as a discrete object that has properties basically written into its code.
Like it's hardwired.
Right. An electron just inherently has a specific mass and a negative charge. It's an intrinsic stat, like a character in a video game having 10 hit points.
But the absolute medium model says those stats aren't inherent at all.
No. The intrinsic properties are entirely replaced by mechanical states. What you observe as a distinct particle in a collider is actually just a dynamically stable structural deformation of the fluid.
So it's not a hard shell.
Not at all. The edge of the particle is just a topological boundary defined by fluid continuity constraints. It's the region where the folding density reaches a critical mathematical limit, and that limit is specifically related to that 3.34 nanometer fundamental length we discussed earlier.
Oh, okay. So we really aren't looking at billiard balls bouncing around. We are looking at, like, localized whirlpools or tornadoes that only maintain their shape because the surrounding fluid dynamics literally force them to stay intact.
That's exactly it.
And the mass and the charge are really just measurements of how aggressively that whirlpool is deforming the fluid around it.
Think about it this way. If you measure a hurricane, you can record its wind speed, its diameter, its barometric pressure. Right.
Okay.
But the hurricane isn't an independent object. It is a temporary structured behavior of the atmosphere. In the same way, particles are structured behaviors of the absolute medium.
Wow. Okay, but if particles are just twisted knots or whirlpools, what does that actually look like at the atomic level? Like, the proton is the building block of almost all the mass we interact with. How does a sponge knot act like a proton?
To understand the proton, we have to look at vortex rings.
Vortex rings.
Yeah, a smoke ring is the classic example. But instead of smoke spinning in the air, the proton is mathematically modeled as a quantized vortex ring in the absolute medium.
Now, that word quantized gets thrown around a lot in physics. In this context, it just means its circulation is locked to a specific unbreakable value, right?
Yes. The circulation of the proton vortex is mathematically fixed to an angular momentum of Planck's constant divided by 2. And the sheer scale of this is terrifying, honestly. Borua calculates the circulation frequency of this proton vortex ring. It spins at roughly 1.78 times 10 to the 22nd hertz.
Which translates to what exactly?
That translates to over 10 to the 24th revolutions per minute.
A trillion RPM.
Yes.
Okay, if you're listening to this and trying to picture a trillion RPMs,
Yeah.
don't worry, your brain just isn't built to visualize that. I mean, my car redlines at 6,000 RPM. A jet engine turbine might hit 20,000 RPM before disintegrating. We're talking about 10 to the 24th power.
It's unfathomable.
But wait, what exactly is spinning? It can't be a tiny solid ball bearing inside the atom.
No, it is the absolute medium itself. The flow field of the energetic net is circulating. And because it's circulating at that mind-bending frequency, the fluid dynamics generate a massive outward displacement field.
Okay.
The proton vortex acts like a centrifugal pump, aggressively pushing the medium away from its center.
Right, and the math says this outward flow is proportional to +1 over the radius squared. And this is the moment in the paper where a massive light bulb went off for me.
Oh, yeah.
Yeah, because in standard physics, a proton magically possesses a positive charge. It's just a label. But in this fluid model, positive charge is a physical action.
Exactly.
It is literally just the outward mechanical displacement of the medium.
Yeah.
The proton is pushing fluid away. That is its positive charge.
Charge is completely demystified here. It goes from being an unexplained intrinsic label to a simple fluid mechanical reality, the direction of the medium displacement. Positive charge simply means outward flow.
But hold on. If a proton is sitting there in space, spinning at a trillion RPM, constantly pumping the universal fluid outward forever,
Wow.
wouldn't that require infinite energy?
Why?
Because you can't just pump fluid outward into a closed system infinitely. It completely breaks the laws of thermodynamics.
Which is exactly why the electron exists. This is one of the most elegant reframings in the entire paper. Look, in the Standard Model, the electron is just another fundamental point particle that happened to be created during the Big Bang. It supposedly exists independently of the proton.
Just coincidentally hanging out.
Right. But in the AM model, the absolute medium is an elastic continuum. It structurally must enforce a closure condition to prevent the exact infinite energy scenario you just described.
Because if you push fluid out, the fluid has to go somewhere. And eventually the pressure has to balance out.
Exactly. If the proton is generating an outward field, a positive charge, the medium is forced by the laws of fluid dynamics to dynamically generate a secondary structure to perfectly cancel that flow.
To balance the books.
Yes. It generates a sheath vortex with an inward flow field.
And that inward flowing sheath vortex is the electron.
The electron is a mandated dynamically generated closure vortex. Its entire topological purpose is to act as the drain that catches the proton's outward flow, returning the medium to a neutral state at infinity. And the inward pull of that drain is what we observe as negative charge.
Okay, let me put this in a real-world setting so we can visualize it. Imagine a massive, decorative water fountain in a closed indoor courtyard. The proton is the high-pressure jet in the center, shooting water forcefully outward. That outward spray is the positive charge.
Perfect.
Now, if you just have a high-pressure jet in a closed room, the room floods. The system destroys itself. To make the fountain work sustainably, you need a drain. The drain is built in a ring around the jet to catch exactly the amount of water being shot out, sucking it back down into the plumbing.
And the electron is that drain. And, this explains something that standard physics really struggles to answer philosophically.
Okay.
Why do neutral atoms always have a perfectly balanced one-to-one ratio of protons to electrons? In standard physics, it's basically just a statistical balancing act of independent particles. But in the AM model, it's a strict mechanical requirement.
Because if you have a pump pushing fluid out, you mechanically must have a drain pulling fluid in to keep the pressure balanced. Right. So we aren't looking at a tiny solar system of little moon electrons orbiting a sun proton. We're looking at a perfectly balanced fluid pump and drain system.
Yes.
But, okay, if every particle is just a whirlpool or a drain inextricably linked to the fabric of space, how does anything move? Like if I throw a base, how does it move through this dense sponge without getting completely bogged down by friction?
That brings us to the mass velocity saturation law, or MVSL. How objects interact with the medium depends entirely on their structural size compared to the mesh size of the net. The math uses a Heaviside step function as an activation threshold.
A Heaviside function is essentially a mathematical on-off switch, right?
Yeah, exactly. Think of it like walking through a heavy beaded curtain. If you are a single tiny glass bead, let's say an electron or a proton, your size is basically identical to the gaps in the curtain.
Right, because of that 3.34 nanometer scale.
Exactly. You can slip right through the strings without disturbing the overall structure. The Heaviside switch stays off. This is why particle accelerators can easily take protons and electrons and accelerate them near the speed of light. They are perfectly tuned topological defects that slide right through the mesh.
But if I try to throw a baseball through that beaded curtain?
Well, a baseball is a macroscopic clump of trillions of uncoordinated vortices. Its effective radius is vastly larger than the fundamental length of the net. So when it tries to move, the Heaviside switch flips to on.
The switch flips.
Yeah, the baseball snags the curtain. The absolute medium physically resists the movement of large, uncoordinated clumps of matter. The math shows the denominator in the velocity equation becomes huge, and the object becomes anchored by the medium.
And that anchoring effect is what we experience every day as inertia.
Exactly.
It takes energy to push a heavy object because you are literally fighting the drag of the universal net. It makes so much intuitive sense.
It really does.
Okay, so we built a single hydrogen atom. One proton pump and one electron drain. But chemistry gets complicated fast. Carbon has 6 protons, gold has 79. If protons are these violent high-speed vortex rings aggressively pumping fluid outward, shouldn't pushing 79 of them into the tiny microscopic space of a nucleus just cause the entire thing to explode? I mean, the shear forces alone should tear the fluid structure to shreds.
You're completely right. If you just mashed 79 proton vortices together, the shear forces would absolutely be catastrophic. The atom would self-destruct instantly.
So how does it survive?
The vortex topological nuclear shell model proposed by Barua shows how the universe solves this extreme fluid engineering problem. It introduces the architectural necessity of the neutron.
Okay, because in middle school chemistry, the neutron is just described as like a slightly heavier proton that forgot to bring a charge to the party.
Yeah.
It just hangs out in the nucleus adding dead weight.
Right, standard physics treats it mostly as a source of the strong nuclear force to glue the protons together. But in the vortex model, the neutron is a balanced triplet vortex.
A balanced triplet.
Yes. It consists of 3 subvortices, which is what standard physics calls quarks. In the fluid model, these are 1 up vortex with a fluid circulation of positive 2/3 and 2 down vortices, each with a circulation of negative 1/3.
So positive 2/3, minus 1/3, minus 1/3, that equals 0 net circulation.
Exactly. The neutron doesn't pump fluid outward overall, and it doesn't suck it inward overall. It is circulation neutral. But internally, because of those 3 violently swirling subvortices, it is a tighter, denser knot than the proton.
Interesting.
And its specific job in the nucleus is to act as a topological spacer.
A spacer. Okay, let's use another mechanical analogy. Think of the protons as heavily toothed metal gears in a machine. If you take 2 gears that are spinning violently in the exact same direction and just force their teeth together, they grind, they shear, and the machine shatters, right?
Right, they cannot touch each other.
But if you place a perfectly sized idler gear right between them, a gear that absorbs the rotation, redirects the kinetic flow, and prevents the main gears from colliding, the machine runs smoothly.
The neutron is the idler gear. In heavy nuclei, the neutrons physically interpose themselves between the proton vortices. They redirect the extreme fluid flow lines, significantly reducing the destructive shear interference.
Wow.
Yeah, without these neutron idler gears, identical proton circulations would cause the nucleus to immediately tear itself apart.
So the nucleus isn't just a bag of marbles held together by magic glue. It's a highly organized, spatially stratified vortex machine.
Exactly.
And looking at it as a physical machine allows this theory to explain things that standard quantum mechanics usually just shrugs at and calls random.
Hey, true.
Take alpha decay, for instance. Why do heavy radioactive elements spontaneously spit out alpha particles, which are clumps of 2 protons and 2 neutrons?
Well, standard quantum mechanics models alpha decay probabilistically. It relies on quantum tunneling. It essentially says that a chunk of the nucleus just statistically manages to ghost its way through the energy barrier and escape. It's a roll of the dice. But the AM model entirely rejects that probability. It provides a strict mechanical structural engineering explanation.
Structural engineering. How does structural engineering cause radiation?
Okay, so the nucleus has to pack these spinning vortices in specific geometric patterns just to keep the fluid stable. For heavy nuclei, the math shows they naturally fall into icosahedral packing.
Like a 20-sided die.
Exactly. Within that incredibly complex, tense icosahedral structure, the alpha particle happens to form a highly stable tetrahedral arrangement, a 4-sided pyramid. Mechanically, 2 protons and 2 neutrons locked in a tetrahedron is the most robust, indestructible subunit you can build out of these fluid vortices.
So it's like a pre-assembled, super strong titanium brick sitting inside a larger, slightly unstable brick wall.
Precisely. So when a heavy nucleus is strained, say it has too many vortices packed into too small a space and the fluid tension reaches a critical breaking point, the nucleus doesn't just spontaneously disintegrate at random.
Right. Like any physical structure under stress, it fractures along pre-existing topological fault lines.
Yes. The weakest structural links break first. Because the tetrahedral alpha cluster is bound so tightly internally, it survives the fracture and detaches from the main body as a single intact unit. Alpha decay isn't a random dice roll. It is structural failure along defined geometric seams.
It takes something spooky and probabilistic and just turns it into material science. I love that.
It's incredibly grounding.
But if alpha decay is a structural fracture, what is beta decay? I mean, beta decay is arguably the weirdest thing in nuclear physics. A neutron just spontaneously decides to turn into a proton, and in the process, spits out an electron and a ghost particle called a neutrino. How does a fluid model explain a particle shapeshifting and creating new particles out of thin air?
Okay, to appreciate the fluid explanation, we have to look at why beta decay was such a nightmare for early 20th century physicists. When they first observed beta decay, they measured the energy of the neutron before the decay, and then the combined energy of the new proton and electron after.
Yeah.
The numbers didn't match. Energy was missing. And worse, the energy of the emitted electron wasn't a specific predictable number, it was a continuous smear. a continuous spectrum of varying energies.
Which violates the conservation of energy.
Completely. It terrified physicists so much that Niels Bohr seriously considered abandoning the law of conservation of energy entirely.
Just giving up on it.
Yeah. But Wolfgang Pauli said, no, let's just assume there is an invisible, practically massless particle carrying away the exact missing amount of energy in every reaction. He literally invented the neutrino on paper just to balance the accounting ledger.
He just made up a ghost particle to save the math.
And we eventually detected them, so his math trick was physically real. But the Standard Model still views this as a spontaneous, somewhat magical transformation mediated by invisible W bosons. The absolute medium model fundamentally redefines beta decay not as spontaneous particle creation, but as a vortex reconnection event.
Vortex reconnection. Let's try to ground that. Think of a heavily stretched, complexly twisted rubber band. You keep twisting it, adding strain and kinetic energy. Eventually, the structural integrity can't hold the topology. The rubber band violently snaps and rapidly reties itself into a simpler, lower energy knot.
That is exactly what happens to the neutron. The balanced triplet vortex of the neutron is subjected to immense fluid strain inside the nucleus. When it hits a critical threshold, the topological knot snaps. It undergoes vortex reconnection to relieve the pressure, and it reorganizes into the simpler, lower energy topology of a proton vortex.
But wait, when it snaps into a proton, a massive fluid dynamics problem arises, doesn't it? The neutron was circulation neutral, but the new proton is aggressively pumping fluid outward. It's a new positive charge. The system suddenly has an open outward flow.
And as we established earlier, the absolute medium cannot tolerate an open flow. The laws of fluid continuity demand closure. So the absolute instant that outward proton flow begins, the excess fluid circulation from the snapping event is dynamically forced outward and expelled as a freshly generated sheath vortex.
The electron. It's born out of the necessity to plug the leak.
Yes, and the violent snapping of the topology also sends a longitudinal pressure pulse radiating through the universal sponge. We observe that pressure ripple as a neutrino wave packet. The electron and the neutrino were not hiding inside the neutron waiting to get out like clowns in a car.
Right, they are the kinetic shock waves and closure vortices generated by the snapping of the topological rubber band.
Exactly. And this physically explains that terrifying continuous energy spectrum that made physicists want to give up on conservation of energy.
How so?
Because beta decay is a mechanical snapping event of a fluid knot, the reconnection isn't identical every single time. It can release slightly variable amounts of vorticity depending on the exact angle and strain of the fracture. The electron gets part of the kinetic energy, the neutrino pulse gets the rest, and the ratio varies based on the mechanics of the break.
So it perfectly maps to the experimental data without needing invisible W bosons orchestrating the whole transformation.
It's a complete mechanical triumph. And, this structural view extends outward from the nucleus into chemistry, too. Standard chemistry teaches us the capacity rule for electron shells: 2 electrons in the first shell, 8 in the second, 1832, and so on. We visualize these as planetary orbits.
Right, the classic Bohr model.
Yay.
Little planets zooming around the nucleus sun.
But if electrons are inward-flowing sheath vortices in a fluid, they don't orbit in empty space. Their shells are actually interference minima.
Interference minima, what does that look like?
Imagine multiple whirlpool drains operating in a single pool of water. Their fluid flow fields overlap and interact, creating complex standing wave patterns. The electrons naturally migrate to the nodes, the calm spots of this composite wave structure, to minimize energy.
Well, it's fascinating.
And if you apply the mathematics of spherical harmonics to these standing waves, the number of available physical nodes precisely matches the 2, 8, 18 capacity rule.
Wow.
Yeah. The entire periodic table of elements emerges not from abstract quantum rules, but from the fluid interference geometry of vortex flow.
It's an incredibly elegant picture. The mechanical analogies, the clear sponge, the fountain, the gears, the snapping rubber band, they make the universe feel tangible again. But, elegance has tricked physicists before.
Oh, definitely.
String theory is incredibly elegant mathematically, yet it requires 11 dimensions and lacks experimental proof. A fluid model can sound beautiful, but historically, beautiful fluid models die the moment they hit the strong nuclear force. Standard physics relies on gluons to keep the nucleus from blowing itself apart. How does a sponge model survive the reality of quarks?
Well, this is the exact gauntlet Barua throws down. In standard quantum chromodynamics, or QCD, Physicists use a specific mathematical formula to calculate how tightly quarks are bound together inside a proton. It's called the Cornell potential.
The Cornell potential, let's demystify that. What does the math actually describe?
The formula describes the potential energy between two quarks based on the distance between them, and it has two parts. The first is a linear term, which represents the flux tube or string tension.
Okay, so imagine a thick rubber band connecting two quarks. If they're close together, it's loose. But the further you try to pull the quarks apart, the harder the rubber band stretches and pulls back. That's why we can't isolate a single quark. The energy required to pull them apart grows linearly with distance until the rubber band snaps and just creates new quarks from the energy.
Right. And the second part of the equation is an inverse term, which describes the short-range interaction when the quarks are incredibly close to each other. This part acts very similarly to standard electromagnetic attraction.
But here is the critical historical context. In standard physics, they use this Cornell potential equation constantly. But where did it come from? Did they derive it from the fundamental nature of the universe?
No, it is largely an empirical fit.
An empirical fit.
Yeah. In the early days of QCD, physicists were dealing with an absolute computational nightmare. Trying to calculate the interactions of quarks exchanging infinite numbers of virtual gluons requires supercomputers running lattice QCD simulations for months just to approximate the mass of a single proton.
Just for one proton.
So they ran the collider experiments, plotted the data points of how quarks behaved on a graph, and essentially said, hey, this linear plus inverse equation fits the curve pretty well. They retrofitted the math to match the experimental reality.
They reverse engineered the math. But Barua takes a completely different path here. He doesn't guess the equation. He derives the exact Cornell potential formula entirely from the first principles of classical fluid mechanics.
Let's break down how he gets from a stretchy, invisible net to the specific force that binds quarks. We start with the linear term, the rubber band effect, the string tension. To calculate this, the paper uses the Michaux scaling law. This calculates the folding density amplification of a quark.
Which is how tightly the sponge is twisted.
Right. By comparing a quark's mass to a standard nucleon, the law reveals that the folding density of the absolute medium at the location of a quark is amplified by a staggering factor of 10 to the 12th to 10 to the 15th compared to ambient space.
The knot is squeezed a quadrillion times tighter than the space around it. That's insane.
Now imagine pulling two of these ultra-dense quark vortices apart. Because of the extreme density and fluid rotation, you stretch the medium between them, creating a literal flux tube of strained space. Because this structure is dictated by the fundamental net, the cross-sectional area of this tube is simply pi times the fundamental length squared.
Just the basic geometry of a circle
Yeah.
using our 3.34 nanometer mesh size.
Right. We then calculate the energy stored in that stretched fluid tube. The medium is maximally stretched, so the kinetic strain is roughly equal to 1. We plug this into the nonlinear elasticity equations of the absolute medium and mathematically isolate the energy per unit length. This gives us our string tension.
And this is the moment of truth. Theoretical physics is littered with equations that look great on chalkboards but fail in the real world. Does Barua's derived tension actually match reality?
He plugs the foundational baseline constants of the absolute medium into his derived equation. He uses the 2.1 times 10 to the negative 26th ambient density, the 3.34 nanometer length, the calculated folding density, and the equation yields a string tension of roughly 0.5 giga-electron volts per femtometer.
0.5 GeV per femtometer. And what is the actual experimentally measured value of the strong force string tension that supercomputers take months to calculate using standard QCD?
The standard QCD accepted value is roughly 0.89 GeV per femtometer. The absolute medium model, derived entirely from classical macroscopic fluid constants without a single piece of empirical tweaking, hits 0.5.
That is staggering. It is within a factor of 2. In foundational theoretical physics, deriving a constant purely from first principles and landing in the same order of magnitude is a monumental victory. It's like predicting the exact breaking strength of a steel bridge just by knowing the ambient temperature of the city it was built in.
It's huge.
What about the other half of the equation, the short-range interaction?
For the short-range inverse term, Barua calculates the vortex induction. Two quark vortices interact physically via their fluid circulation fields. If you remember high school physics, the Biot-Savart law describes how magnetic fields are generated by electrical currents running through wires.
Right.
Here, Barua applies the exact same classical mechanics, but instead of electrical current, he uses the literal fluid circulation of the absolute medium. He calculates the mutual kinetic inductance of two thin vortex rings interacting at close range.
And when he crunches the constants for this vortex induction,
It yields approximately 0.5 GeV femtometers. The standard QCD short-distance Coulomb coefficient derived experimentally is about 0.25 GeV femtometers. Again, a match within a factor of 2.
you're telling me we might not need gluons. The entire field of quantum chromodynamics requires these invisible, force-carrying point particles constantly ping-ponging back and forth at the speed of light just to hold a proton together.
Yeah.
And Burrow is saying that's an unnecessary hallucination.
That is the direct implication, yes. This derivation effectively eliminates the need for the gluon. It replaces the magic of invisible messenger particles with calculable fluid dynamic string tension and classical vortex induction. The strong nuclear force is rescued from the abstract weirdness of the quantum realm and placed firmly back into the realm of classical continuum mechanics. The math works.
Wow. But wait. If the strong nuclear force is just fluid tension and vortex induction, what about the rest of the fundamental forces? For over a century, the absolute holy grail of physics has been a theory of everything, a unified field theory, one single equation, one Lagrangian that unifies gravity and electromagnetism. Albert Einstein spent the last 30 years of his life chasing it and died empty-handed. Does this paper claim to have found it?
It does. Barua provides a single unified field formulation, a solitary Lagrangian equation that dictates both electromagnetic and gravitational effects simultaneously, all arising from the dynamics of the exact same absolute medium.
I am extremely skeptical. Gravity and electromagnetism behave incredibly differently.
They do.
Gravity is overwhelmingly, almost laughably weak. It takes the entire mass of the planet Earth just to pull my coffee cup down to the desk, and I can overcome the gravity of that entire planet just by lifting the cup with a few muscles in my arm. Yet, electromagnetism is insanely strong. Static electricity can lift a balloon against gravity easily. Furthermore, gravity only ever attracts. It pulls. Electromagnetism attracts and repels. How can one single fluid equation possibly explain both of these completely divergent behaviors?
It is the ultimate paradox of modern physics, and Barua solves it by deconstructing the universe into just two variables. Everything in that Lagrangian equation, every force, every interaction, originates from the dynamics of two simple properties of the fluid. The first is the scalar density field. This is simply a measurement of how dense the sponge is at any given location. The second is the four-velocity field. This describes the flow, the kinetic movement, and rotation of the medium in spacetime. Density and flow, that is the entire universe.
Okay, walk me through how density generates gravity.
The Lagrangian contains a potential energy term that represents the gravitational sector. Gravity emerges entirely from the density-dependent pressure gradients of the fluid. When the medium folds into a knot to create matter, the local density skyrockets. This creates a massive pressure gradient in the surrounding fluid.
Like a severe low-pressure weather system dragging surrounding air inward to fill the void.
Exactly. Gravity is just the universal fluid constantly trying to equalize its own pressure. And because it relies purely on scalar density, it has no orientation. It only ever acts as an attractive, pulling force toward regions of higher density. And because it is a bulk property of the ambient fluid, which we already established is incredibly light, the resulting force is extraordinarily weak on microscopic scales.
That perfectly explains the weakness and the singular attraction of gravity. But how does that same fluid generate the violent push and pull of electromagnetism?
For electromagnetism, we look at the kinetic part of the equation. The equation has a specific term, an antisymmetric tensor, that basically calculates how violently the fluid is shearing, swirling, and circulating. It's the mathematical equivalent of measuring the rip currents and whirlpools in our cosmic ocean.
Wait, are you saying the magnetic field is just the physical rotation of space itself?
Literally, yes. In standard physics, a magnetic field is an abstract invisible force. In the AM model, the magnetic field is the actual physical circulation, the vortical flow of the medium, and the electric field is the radial displacement flow, the inward or outward pumping we talked about with the proton and the electron. Electromagnetism is incredibly strong because it deals with the violent, concentrated, high-speed kinetic circulation of the fluid right at the particle scale. Gravity is weak because it deals with the slow ambient pressure gradients of the bulk fluid across vast distances.
And the particles themselves, the mass.
Matter simply emerges from the structural constraints placed on that flow. The topological knot forces the fluid to aggressively rotate, creating electromagnetism, and simultaneously increases the local density, creating gravity.
Gravity is the pressure of the fluid. Electromagnetism is the swirl of the fluid. Matter is the knot in the fluid. It's all just water in different states of kinetic motion. It tells us that electromagnetism and gravity are not separate, distinct forces fighting each other. You don't need independent photons to carry electromagnetism and hypothetical invisible gravitons to carry gravity. They are just complementary kinetic projections of the exact same absolute medium. It is ontologically breathtaking.
It really is.
But as we said earlier, elegance is not proof. A theory without testable predictions is just a campfire story. If this framework is going to overthrow a century of established particle physics, it has to predict things that the standard model gets wrong. What are the smoking guns? If there are experimental physicists listening to this deep dive right now, what should they be looking for in their particle colliders tomorrow to prove Barua right?
Barua lays out 4 incredibly specific, highly falsifiable predictions. These aren't vague guesses, they are rigorous mathematical targets. If even one of these is empirically observed, it shatters the standard model paradigm.
Give me the first smoking gun.
Number 1, flux tube substructure. We talked about the strong force being a flux tube of stretched fluid between quarks. Standard QCD treats this flux tube as a smooth, continuous field with no internal geometric structure at the microscopic level. The AM model fundamentally disagrees. It predicts that this flux tube is made of the net, and therefore must have a characteristic geometric width of exactly our fundamental length, 3.34 nanometers.
How do you look for a 3.34 nanometer structure inside the chaos of a particle collision?
You look at ultra-high-energy heavy-ion collisions, like the ones they run at the Relativistic Heavy-Ion Collider. By analyzing the trajectory patterns of the debris, specifically something called dye-jet correlations, physicists could look for a microscopic geometric signature, a literal ripple in the debris field, at exactly that 3.34 nanometer scale. If they find that substructure, the fluid model is validated.
What's the second prediction?
Number 2, super heavy magic numbers. This deals with synthesizing new artificial elements with massive numbers of protons and neutrons. Standard nuclear physics predicts that as we force more and more protons together, we will eventually hit an island of stability, a super heavy element that doesn't immediately decay. The standard model, based on quantum orbital calculations, strongly predicts this island of stability will occur when we synthesize an element with an atomic mass around 184.
Standard physics has been chasing element 184 for decades. They are building massive colliders right now, specifically targeting that mass. Does the fluid model say they're wasting their time?
It says they're shooting at the entirely wrong target. Because the AM model uses rigorous physical structural packing geometry instead of abstract quantum probability, it mathematically proves that the structural limits of icosahedral packing will force a geometric collapse much earlier. It strictly predicts the island of stability will occur around mass number 164.
164 instead of 184. That is a stark binary difference. When experimentalists finally synthesize these elements in the coming years, one theory will be right and the other will be definitively dead. What about prediction number 3?
Number 3, exotic nuclei vortex lattices. In certain extreme laboratory nuclei, where you artificially cram in a massive imbalance of neutrons compared to protons, the standard model assumes the nucleus is just a dense, somewhat unstructured drop of quantum liquid. But the AM model says the fluid dynamics will force those extreme neutron vortices to organize into highly regular geometric lattices to survive the shear forces.
Like the hexagonal honeycomb patterns you see in freezing water or certain crystals.
Exactly like that. Specifically, they would look like the Abrikosov vortex lattices we currently observe in superconductors. The paper suggests these microscopic honeycomb lattices would manifest as periodic density fluctuations inside the nucleus. If we use high-resolution electron scattering, basically shooting electrons through the exotic nucleus to map its interior, and we see a honeycomb diffraction pattern, it's definitive proof of a structured fluid interior.
And the final prediction.
Number 4 takes us back to beta decay. Remember the snapping rubber band, the topological reconnection event. Because it is a mechanical untying of quantized fluid circulation, the energy release cannot be perfectly smooth. The standard model says the continuous energy spectrum of the emitted electron is a perfectly smooth statistical curve.
But the absolute medium model says a snapping knot has to stutter.
Precisely. Barua predicts that if you look closely enough at that continuous energy curve, you will see tiny periodic modulations, little stutter steps or ripples in the data at the microscopic level of 10 to the negative 4. These ripples are the literal kinetic shock waves of specific, quantized chunks of fluid vorticity being released as the knot unties itself. High-precision neutrino mass experiments currently coming online might just have the optical resolution to see this stutter.
If they find a 1 in 10,000 ripple in the beta decay spectrum, the standard model has absolutely no mathematical mechanism to explain it. The absolute medium model predicts it as a foundational necessity. It is incredible how built these targets are. Confirming just one of them would trigger the greatest scientific revolution since relativity.
It truly would.
We have covered an immense amount of conceptual ground today. We started by discarding the comfortable middle school textbook idea of point particles, the comforting illusion of solid dots bouncing around in an empty void.
We replaced that empty void with an elastic, continuous, energetic net. We reframed particles entirely. We saw how protons are not solid balls, but quantized, high-speed fluid vortices pumping the universal medium outward, creating the mechanical reality we mistakenly call positive charge.
We realized that the electron is not an independent actor in the universe, but a dynamically generated drain, a necessary sheath vortex required by the laws of fluid dynamics to close the system and prevent the universe from drowning in infinite energy flow.
We explored the nucleus as a structural machine. We saw neutrons acting as topological idler gears, smoothly redirecting fluid flow to allow protons to coexist without shearing each other apart. We watched the spooky magic of radioactive decay unfold as simple material science, the structural fracturing of geometric fault lines, and the mechanical snapping of overstrained topological knots.
We walked through the grueling math of the strong force, seeing how the Cornell potential, the equation holding reality together, derives perfectly from classical fluid tension and vortex induction, completely eliminating the need for hallucinatory, invisible gluons.
And we witnessed the ultimate unification. A single, elegant Lagrangian equation that beautifully intertwines the bulk, weak pressure gradients of gravity with the violent, high-speed vortical shears of electromagnetism. A universe built entirely of density and flow.
It is a lot to process, and it challenges the very foundation of how we are taught to perceive reality. But I want to leave you, listening right now, with a final provocative thought. Something to deeply mull over the next time you look in the mirror, or hold your smartphone, or look up at the night sky. If Sriman Barua's absolute medium theory is correct, there is absolutely no such thing as empty space. The void does not exist. The idea that you are an isolated collection of tiny solid particles wandering alone through a cold, dead, empty vacuum is a fiction. You are a highly complex, dynamically sustained series of topological knots. You are a beautifully organized turbulence in a universal living net. And because it is one continuous net, you are physically and mechanically connected to every other knot in the cosmos. Every breath you take, every movement of your hand creates a literal kinetic ripple in the exact same continuous fluid that forms the burning heart of the stars. The X-ray machine of standard physics might be broken, and the diagnostic waters of the quantum realm might be murky, but the fluid connecting us all is absolute. Thank you for joining us on this deep dive into the energetic net. Keep questioning the void.